If you were to take two identical containers, one filled with a mysterious gas and the other with hydrogen, and weigh them, that ratio would tell you something profound about the hidden world of molecules. This ratio is what we call vapor density. But how exactly does this simple measurement of heaviness lead us to the molecular weight of a substance? To find out, let's start with the formal definition of vapor density. Imagine we have a specific volume, let's call it V, of a gas at a certain temperature and pressure. As you can see on the screen, vapor density is defined as the mass of this volume of gas divided by the mass of the same volume of hydrogen gas under those exact same conditions. At first glance, this looks like a macroscopic measurement, something we can do with a scale and some glassware. But here's where the key insight comes in. Around 2 centuries ago, Amedeo Avogadro proposed that equal volumes of all gases, at the same temperature and pressure, contain an equal number of molecules. Let's visualize this. Picture our two containers again. Even though the gases inside might be completely different, Avogadro tells us that if the volumes are the same, the number of molecules inside must be the same too. Let's call that number N. Because we know there are N molecules in each container, we can rewrite our ratio. Instead of talking about the mass of a whole volume, we can say vapor density is the mass of N molecules of our gas divided by the mass of N molecules of hydrogen. Now let's simplify. If the ratio holds for N molecules, it must hold for just one single molecule. Notice how the N cancels out, leaving us with a much more intimate look at the substance. The mass of one molecule of the gas divided by the mass of one molecule of hydrogen. But wait, there's a crucial detail we need to account for. Hydrogen doesn't like to travel alone. It exists as a diatomic molecule, H2. This means one molecule of hydrogen is actually composed of 2 hydrogen atoms. So let's look at our equation again. We can now say vapor density equals the mass of one molecule of the gas divided by the mass of 2 atoms of hydrogen. If we pull that 2 out to the side, we're left with the mass of one molecule of gas divided by the mass of one hydrogen atom. Does that look familiar? In chemistry, the ratio of the mass of one molecule of a substance to the mass of one hydrogen atom is the definition of molecular weight. And there it is, the aha moment. By substituting this definition back into our equation, we find that vapor density equals molecular weight divided by 2. Or to put it in its most common form, molecular weight is simply twice the vapor density.